In this example, we're going to consider a relatively straightforward case of probability where we have two events that may or may not be independent. We don't know. We're instead given very specific information, which I'm going to try to describe using a Venn diagram. So we'll just have our sample space S, and we're going to have an event A that has a probability of 0.5, so I should draw it pretty big. It constitutes about half the area of the Venn diagram if I'm trying to depict it approximately correctly. And then when we draw an event B, we know that there is an intersection and it's equal to 0.1 or 20% of A. So we want to have an intersection of 0.1, but we also know that the intersection of not intersection, but we know that the probability of A union B, which is A or B, or you're in one or the other circle, is 0.8. So B is pretty big, and we know that the portion of the probability that you're inside both is 0.1. So what's the probability that you're in A but not in B? And I'll just put in some shading to help depict what I'm trying to get at. So if I need to put in a probability here, that portion must be 0.5 minus the 0.1. So that's 0.4. So how much in the portion that I'm shading here in B? What must that be? Well, we know that A union B is 0.8. So when you add it up, sorry, I didn't draw that very well. When you add up these three different portions, they must be 0.8. So we know that you must have 0.3 here. So what's the probability of B? Well, we have two different portions. One that's inside A, 0.1, plus the portion that's outside A, 0.3. So that probability of B is 0.4. And that's the answer.